everyone. So today we're going to talk about even and odd functions and how they are symmetrical. So even functions are functions that are symmetrical around the y-axis. So I like to call these my yeah functions. So around the y-axis, you have even functions. So the example on the left is an even function. And odd functions are symmetrical around the origin. So I like to call these your ooh functions. So the graph on the right is an example of an odd functions. So yeah functions and ooh functions. So with the even function, you'll notice that the x is the only thing that's changing. So in an even function, only the x changes. Okay. In an odd function, what you'll notice is that both the x and the y change. So both change in an odd function. So let's look at some examples on even and odd functions, and we'll also use some algebra as well. So if a point 39 lies on the graph of an even function, so even, identify another point that's on the graph. So if it's an even function, the thing that you should remember is that your x is the only one that changes, right? So if I take that 3, I'm going to make it a negative 3. So another point that could be on this graph is negative 3, 9. If I have a point negative 4, negative 8, and it's on the graph of an odd function, well, I have to remember that both are changing in an odd function. So I'm going to take the negative 4, it's going to turn positive, and then I'm going to take that negative 8, and it's also going to turn positive. So another point that could be on the graph is a 4, 8. Okay, so here you're given a function, and you need to determine whether the function is even, if it's odd, or if it's neither. And if you get an even or an odd function, let's go ahead and describe what that symmetry is on. Okay, so the first thing I want to do is check, okay, well, algebraically, can I show whether this function is even? So let's look at even. So here's this algebraic test. So f of negative x, which means I'm going to take all of those x's and I'm going to substitute those in for a negative x. So I'm going to take negative x to the 4th power minus 4 and then negative x squared. Notice what I did is I took parentheses whenever I've got that little negative x there. All right, so let's go ahead and simplify, and we're going to check. If I simplify this, I get x to the 4th, and then I get a negative 4, and then I still get x squared. Now notice that my answer is actually the same. It's the same as my function here. So what that means is that this is actually an even function. So that algebraic test was that if I take f of negative x, well, after I simplify, I should get my same function. So because it's even, we are knowing that it's a yeah function, so it's symmetrical around your y-axis. All right, let's look at another example together. So here we have another function, kind of same idea. So let's check first and see, is this function even? So we always do that even test first. So we've got f of negative x. We're going to take each of these x's and we're going to substitute, replace that. So we got negative x to the 3rd power minus another negative x. Very, very important to have those parentheses there. All right, so when I simplify, I'm going to get still a negative x to the 3rd, and now I'm going to get a plus x. So what you should see is that, well, I know it's not even because it's not exactly the same. It's not that same function that I started off with. So then you're going to do your test to see whether it's odd. So with odd, what you're going to do is you're actually going to take out a negative. So I'm going to factor out a negative there. And I'm going to see, all right, x to the 3rd minus x. Okay, so now if my function right inside gets me the same as up above, then I know that I have an odd function. Now, again, remember, we are factoring out a negative. So that just sort of flips all of our signs, right? So factor out that negative. It's an odd function. So remember your ooh, it's an ooh function. So it's symmetrical around your origin. So now remember that algebraic test is if we took f of negative x, it's got to be the opposite of f of x. Okay, so here we go. One last example for you. Same idea. Let's check. Is it even? If it's even, it has to be the same. If it's odd, it's got to have that negative one on the outside to factor it out, right? If it's neither, well, then it's neither. So let's check it out. So I'm going to take f of negative x and again replace all my x's with that negative x here. And let's simplify. F of negative x, I've got 6x squared. This becomes a minus 5x and a minus 6. Well, I know it's not even. It's not like my original f of x function. So it's not an even function. Well, let's factor out that negative and let's check. Well, if I factor out that negative, let's see what happens. It's going to switch all my signs, right? So it's become a negative 6x squared, a plus 5x, and then a plus 6. Okay, well, if you look here, it's not exactly the same. So it's not an odd function, right? It doesn't match up exactly to my f of x, right? So if it doesn't get you either even or odd, it's neither. So if you found this video helpful, don't forget to like it and subscribe so you get more notifications on other videos. Thanks for watching and have a wonderful day.